In this video, I'm going to talk about when to use constant reference parameters. So let's just review that I have a structure called payroll. Right? It has 4 members inside of it. And then I just really have 2 functions. In a previous example, I had this as a value returning function, but now I'm just making it instead a void function with a reference parameter. Just because I want to talk about reference parameters in general. So you can see here the first function that gets called is get employee data. So when we go here to get employee data, this is a reference parameter. We're going to ask for the employee number, the employee name, the hours they work, the hourly pay rate. It's all going to be stored in this employee variable, and because it's a reference parameter, it's going to be returned back to the main program. So we should understand reference parameters now, and then why they're important. We have them there in case we, for the situation where we make a change in the function to that parameter that we want to go back to the main program. If it's not a reference parameter, right, if there's no ampersand and we make a change to it, when we go back to the main program, that change is not there. So it's important that you have that here. Now, the next function called display, well, then it calculates the gross pay with the hours and pay rate that came back here. So then we go to display employee info. So again, we're going to pass our employee structure and then the gross pay that was created. So when we come here to this display function, we can see that employee is a value parameter. Now generally that would be fine. The purpose of a value parameter is to pass something into a function. And so generally when we have display functions, we have value parameters. That's what we generally do. But now, because we are starting to introduce data structures, which is a group of data, and the structures are an example of that, right? We've got a bunch of stuff packaged together in this particular employee variable. So value parameters become inefficient because when you have a value parameter, it makes a copy. So this employee has 4 members stored inside of it, and we're going to make a copy of it. And that's really relatively wasteful, especially when data structures get larger and larger. It becomes even more wasteful. So value parameters are not a good idea when you start to introduce larger data structures, like structures themselves, and we'll see classes in the next module. So one thing that we can do is we can make them reference, because that won't make a copy. So reference takes away the problem that we're making a big copy somewhere, because a reference shares the memory locations, right? But the problem is when something is a value parameter, if a change is made inside the function, that change doesn't go back to main. Well, as soon as we make this reference, if a change is made here, it will go back to main. And that's kind of counterintuitive to using, a value parameter. So what we want to do here instead is to use the reserved word const. Right, I've got to do it here, and I've got to, of course, make the same change up here. All right, so this is referred to as a constant reference parameter. It is reference to save on space and also save on time, because you don't have to take the time to make a copy of it, but the const in front of it means if somebody makes a change in here, it's not going to go back to main. And in fact, by putting const in front of it, somebody can't even make a change here if they wanted to. So the benefit to a constant reference parameter is that it's like a value parameter, but it saves on space and it saves on time. So when data types become bigger, when they become data structures, right? We don't really want to use value parameters with these things. We want to save on space, we want to save on time, we want to be efficient. And so that's the way to do it. Now, as soon as I show people this, I start seeing people put const in front of doubles and simple data types. You should not be using const in front of simple data types, only in front of data structures. Now, in the previous module, when we looked at arrays, we put const in front of arrays. The same rationale. It's just they're still constant reference parameters just like this, except an array is automatically a reference parameter, so you don't need the ampersand there. So it's the same concept, but it's really an important concept for you to understand and for you to use in your programs. So when your data types become larger, when they become data structures, you should either use reference if they're being changed, like in this example, or constant reference when they're not. And again, constant should be reserved for, as far as what we know in our class right now, structures, and it can be used in front of arrays. It should not be used in front of any simple data types.